Z-scores day number 1. We just got done talking about the normal curve, and the normal curve has rules. If you're 1 standard deviation away, 2 standard deviations away, 3 standard deviations away. What this is for is if maybe you're not exactly a whole numbered standard deviation away from the mean. Okay, anyways, we're going to introduce a couple more variables. One of them would be your Z-score. It's how many standard deviations away you are from the mean. X would be your observed value. Mean is that U-looking thing, and standard deviation is the over the little curve. They're actually 2 Greek letters. So anyways, how many standard deviations away from the mean? So this is that old rule I was talking about. If your Z-score was 1, you're 1 standard deviation above and below. If it's a positive 1, that means you're above the mean. If it's a negative 1, you're below the mean. If it's a positive 2, you're 2 above. And if you're 2 below, it's a negative 2. Okay, so this works all fine and dandy if you're exactly 1, 2, or even possibly 3 standard deviations away. Now, what I've got an issue with here is that I've got this area underneath the curve. What we're going to do is we're going to find the Z-score for the daily production of 2,100, given that the mean is 2,180 units and the standard deviation is 50 units. Okay, well, to get to 2,100, I didn't go 1 standard deviation away to the left or even 2. It's somewhere in between. So what I'll do is find a Z-score. So I'll take my observed score minus the average. Okay, so that's that Greek symbol there, and divided by the standard deviation. Okay, now since I'm to the left of the average, I should get a negative Z-score. So I'm just going to type that into my calculator. I don't know why I did that. It's negative 80 divided by 50, and that gives me a Z-score of negative 1.6. And we'll talk more about what that means in a bit in terms of probabilities and areas. But for now, I just know that that is your 1.6 standard deviations below that average unit. Okay, do the same thing here. We're just going to take some Z-scores or raw scores and convert them into Z-scores. I've got my mean that is 30 and a standard deviation of 5. Okay, so I'll take my observed score of 40 minus 30 divided by 5. So 10 over 5, so 2. Which makes sense, it's positive 2 since 40 is bigger than 30. So when I find a Z-score for 25 minus 30, that's negative because 25 is less than the mean. I'll end up with a negative 5 over 5. So negative 1. Okay, Z-score for 31. So I'll just take 31 minus 30 over 5. So 1/5, so 0.2. And then finally for 18. Now, if I'm going really fast, you can slow us down however you want, but it's going to be negative 12, I believe, over 5, which is a negative 2.4. Okay, which ones were above the mean? 40 and 31, they had positive Z-scores. Which ones were below the average? 25 and 18, so I got negative Z-scores. Okay, so here's what I'm going to do. I am going to help you calculate, let's see. Midterm normal, standard deviation, calculate the Z-scores of the following. Okay, so it's just the Z-scores again. But this time I'm going to draw and sketch something to go along with it. So, divided by standard deviation of 6.3. So 65 minus 81. Divided by 6.3. Yeah, so I get a negative 2.539, but I'll round it to 5.4. So if I make a sketch of that, my mean is going to be 0 in the middle. Negative 2.54 is down here. Okay. 83 minus 81 over 6.3. So 2 divided by 6.3. 0.31 or 2, round to the nearest hundredth. I'll explain here in a little bit. So there's 0, so it's just going to be roughly a little bit bigger than that. Okay, 93 minus 81 over standard deviation of 6.3.
I thought I assigned to these chairs. I don't like them. Where are my jeans on? That's why we're all summer. We don't have school in the summer.
Okay, 1.90. So that's going to be roughly about right there. Okay, so here we go. How do you know which one's better or not? So what you do is you could find the z-score. The higher the z-score, the farther away from the mean. Okay, so a class has an average of 75, standard deviation of 10, unit 10 test, standard deviation of 6. The z-score is 1.25. What is his actual score? So what I'm going to do is I'm just going to take the same formula and plug in what I know here. So my z-score 1.25, raw score minus 75 over 6. So I'll multiply by 6. Add the 75. So his raw score was an 82.5. Okay, now Emily's got a negative z-score, so negative 0.45. Same test, so the average was 75 and the standard deviation was 6. Multiply by 6. Add the 75. And x is 72.3. Okay, now I kind of knew that her score was lesser than his score because of the z-scores. This is a bigger one, and this is negative. So that's kind of telling me I know that's below average. The positive one tells me it's above average by 1.25 standard deviations. So before you apply to law school, okay, so here we go. You've got LSAT and whatnot. Here's the average for the LSAT, and here's the standard deviation. Here's the MCAT. It's mean and standard deviation. Juwan took both exams. He scored a 175. Now, by finding the z-score, you can make that all relative to the same average and standard deviation. So if I find the z-score for his LSAT, 172 minus 151 over 10. And if I find the z-score for his MCAT, so let's see what 37 minus 25.1. The z-scores will tell me a better representation of how closely he did to that average. Because you got one value that's in the hundreds, so z-score here for this one 2.1. You got another value that's in the tens. It's kind of difficult to compare them until you knock them down into a common way of comparing. So those are the two z-scores. He did better because this is higher than the mean by more standard deviations.